quick.
Hello. Hello, good afternoon from Kuala Lumpur, and good morning, good evening, wherever you are coming from. Well, warm welcome to the second day of this technical workshop. As you know, this is the workshop jointly organized by the Asia Pacific Broadcasting Union, Arab States Broadcasting Union, and the World Dev. We know that ABU is hosting the session, but we have all the experts from World Dev and of course some speakers from ASBU as well. We know that we are in the second day today, and we have lots of exciting topics for today. So at this point, I would like to invite Dr. Les as your moderator for the next 90 minutes. And Dr. Les will introduce you through today's agenda and presentations. So let me invite Dr. Les here. Yeah, Dr. Les, you're on the screen. Please, over to you. Thank you.
Thank you very much, Sri. Thank you to ABU for hosting this webinar today. As mentioned, a joint webinar with the ASBU and World DAB. Today is the second day, and today we will be focusing on getting started. We have a great lineup of industry experts to speak with you and share their knowledge. We'll just quickly run through the agenda, and we can see here in fact, in the introduction we're going to have Dr. Adnan first. He's going to give us a little bit of an update on some questions we had yesterday about DAB in the Arab States. I will then talk briefly about give an update on DAB system features. We'll then move on to equipment topics in DAB head-ends with Mr. Wolfgang Peters from AVT Audio Video Technologies on head-end systems, and then talk about transmission systems with Mr. Alexander Kurz from Gates Air for that. And then we'll go into our panel session. And this panel session is highlighting the initial steps in DAB+, and we have speakers from South Africa, Mr. Dave Cherry. We have Ms. Orazri Sriraza from Thailand, and Mr. Kamal Haj Amar from Tunisia, which will share their experiences in how they have been going along the road to develop DAB in their countries. And then we'll have our Q&A. Q&A, please use the Q&A box at the bottom of the screen. Type your questions in there and we will answer them as much as we can at the end of the session. We went over a little bit yesterday because we had so many questions. So hopefully we'll have a similar situation today. So I'll now stop sharing and I will hand over to Dr. Adnan Salab to give us a quick update on Arab states. Over to you, Dr. Adnan.
Thank you, Dr. Les. Quickly, regarding the raised question yesterday about the implementation progress in Egypt and other ASPO members, I would like to clarify 2 points. The first point that the technical committee of ASPO put forward the specifications of DAB receivers and approved it from 2018 and recommends the members to apply this specification from 2020. ASPO also recommended the members to take forward steps in issuance of the adequate necessary legislation to include digital broadcasting specification for all cars supplied to their countries. The second point that the regulation and legislation to implement the DAB+ to automotive, home, and portable services is the most important step, which should be taken by each country. This step is not yet completed at the most of the Arab countries. As a conclusion, I can say that during the last 3 years, due to Corona and economic circumstances, unfortunately, the progress of implementing DAB+ went slower. However, the situation is different from country to other. While some action were taken in some countries to be the DAB+ receivers mandatory for new vehicles, like in Saudi Arabia, Tunisia, and so on, there is no update from the others. I talked yesterday with Mr. Kamal Al-Haj, who is the chairman of working group of transmission at ASPO. He will try, in addition to his presentation about the situation in Tunisia, he will try to give us more information about the progress in DAB+ in the Arab country. Sorry for not give you more detail. That is all what I have. Thank you.
Mr. Liss.
Okay, thank you, Dr. Adnan. Just to help
Mr.
us
Liss,
bring us
Dr.
up to
Liss.
date. Yes.
I'm Kamal. May I add some about the question of yesterday, if you don't mind, just to add something about, especially for Saudi Arabia, because I have some information about DAB
Sure,
trials
okay.
and experiments.
Okay, that's
Thank
good.
you very much.
Things are happening
you
in
very much.
Saudi Arabia.
Yeah.
Please carry on.
I want just to add special thanks what said Mr. Adnan. So the question yesterday was about DAB receiver. Is it mandatory for new vehicles, especially in Arab wars, or and especially in Saudi Arabia? So let's say that in most of Arab countries, as said Mr. Adnan, not really legislative bodies are installed. Especially only in Saudi Arabia and Tunisia, we are actually trying to put something in the coming years. Saudi Arabia has introduced legislation requiring radio receiver to be equipped with terrestrial DAB capabilities. So according to the legislation in Saudi, starting from January 2021, all home receivers, portable receivers, and vehicle receivers are required to be equipped with DAB+ standard. And maximum 2024, all cars that will be sold in Saudi Arabia will be with a hybrid system, AM, FM, and DAB system. Actually, in Saudi Arabia, they are trying to ensure the coverage along 5 highways with DAB system from Riyadh, Dammam, Medina, Mecca, and Riyadh, Mecca. So this is what he's actually doing in Saudi Arabia. In Tunisia, we'll see afterwards that we are really endeavoring to pass a law stating that all devices sold to consumer and the automotive industry have to be capable of receiving digital radio. And we hope that by the end of 2024, we will have this law studied in Tunisia. Regarding other Arab countries like Egypt, Algeria, Oman, Jordan, Kuwait, they have actually just a trial period experimentation. They have some interest starting from 2017 and 2019, but regular transmission is not really done as today. Thank you.
Okay. Thank you for that further update. You know, I think that is showing progress, and I'm particularly encouraged by the adoption of the European EECC approach to mandate digital radio in new receivers. It always makes a big difference when you establish a market if you've got some prior commitment to those receivers, and maybe even have some in service in cars in particular prior to permanent services being established. Good stuff. All right. Well, let's move on. I will now talk briefly about DAB system features and receivers as well. I'll just share my screen. Okay. So hopefully everybody can see that okay. So we're going to talk about broadcast features, briefly about receiver overview, and I want to focus a little bit on hybrid radio operation. So the first thing here is, and we've had some questions on this already actually from yesterday. The first thing is that DAB is a digital data delivery system optimized to provide high quality audio for multiple audio and data services on a single transmission. That transmission system is an IFDM based system with multiple carriers, but with a single center frequency. We call that a frequency block. Typically, we get 18 to 24 DAB services on one transmission. The audio bitrate can be adjusted to provide the quality required for the type of material, the type of audio being transmitted. So if we've got pop and rock, it's usually a lower bitrate, like 48 kilobits. The more noisy the format of music, the lower the bitrate required. Interesting. The higher bit rates are usually used for music genres like jazz and classical and some folk music. Of course, we have our program associated data as well, which is in the form of text and slideshows. And we also have a number of advanced features as well. We'll talk about it a bit more. Okay. So the first thing we know is we have room for lots of services. Here's an image of the AM and FM services in Australia and the main cities that were established first before DAB. And this is what it looks like after DAB. In fact, this slide is a little bit older than I'd like. And there are actually more services than even shown here now. In Sydney, we have over 80 services where we had less than 20 FM and AM services prior. So that means lots more new music, lots more new talk shows and so forth, something hopefully to provide entertainment and information for everyone. In terms of broadcasters, the opportunity here to expand your brands. And that's exactly what I'm talking about. In UK, we see Heart, they added Heart Extra. So they've went from 1 to 2 stations. In Norway, an example is in P1, they added P1 Plus. And of course, a lot of other stations are using this same model. BBC is using it as well. And it's often referred to as a brand extension strategy. And the example I have here from Australia is from the Southern Cross Stereo Network, where previously they had 2 FM services in each city, Triple M and Hit, and they've extended that to have 5 additional services for each of those. So now rather than have 2 stations, they have 12 stations. And certainly is making a difference. And I mentioned yesterday the uptake of DAB in Australia has been advancing quite significantly in the last year or so. This is one of the reasons. Also, we have the opportunity to do pop-up stations. The good thing with DAB is you can not only set your main bitrate for your services according to the type of content, but you can also dynamically change that bitrate. And in some cases, you might want to add 1 extra station for a while, and you might take a bit of bitrate from some other services that you have to create that pop-up station for a short time. There's a few examples here. Elf Radio around Christmas time. We have Olympics Live. That was when Olympics was in the UK. We have emergency situations like the Queensland flood appeal a few years back. That was a new station established just for that massive flooding event over about a week period. Or you might have something like the main stage, which is a pop-up. It only happens for a couple of hours and covers new artists that are coming to the country to do concerts and things like that. So all manner of opportunities. Now, one of the really good things about digital radio is we don't choose by station frequency anymore. We choose by the actual name. Here's some examples here of that. So we can choose by name, not by number. And that makes life a lot easier for everybody, especially when you've got such an increase in services. Imagine if you had to remember every FM frequency that you really wanted. I like to listen to multiple different stations. I'm sure other people do too. We have our text from our program associated data. Here's a couple of examples here. Pretty straightforward stuff. Now playing information, information about the station, maybe a news ticker, weather ticker, things like that. And a good example here is some of the new radios that are coming out. This Albrecht in particular is a lovely little radio, and it will show you the slideshow at the same time as the text. So slideshow is something really useful. Not only can it show you album art, as we see down here for the BBC, and over here, it can show weather information, logos for the station, so keep people informed. We can see that in a couple of places too, and other things, whatever you want, whatever the broadcaster wants to put up here, within decency limits, of course. Also, we have data services, and TPEG traffic is a good one, capable of showing current congestion, traffic flows, fuel locations and prices, parking. We can do examples of text-based services too through Journalline, very popular in Germany. And if you wish, you can actually develop a custom application. It's quite easy to do. All the information is in the standards to do this. We have our advanced features for service and program information, giving things like station logos, links, taglines, program schedules. We have our announcements and emergency warning system, which can provide not only just the emergency warnings, which we talked about quite in detail yesterday. If you missed yesterday's session, you'll be able to catch up on that afterwards, either by the YouTube link or via the individual presentations that'll be made available after day 3. And of course, it's not just emergency, it's other things such as traffic information, news, weather, other warnings, and so forth. And of course, we have our service following. So when we're moving around the country and we need to move between different areas, we can often track that and keep listening to the same service as we move across the country. So moving to receivers, well, they're very much now mass market, over 100 million receivers sold. I think it's more like 120 million now, including cars. Prices from $20 US. That was what was mentioned by our World DAB president yesterday, Patrick. Here's some examples from the internet. In Australian dollars, in fact, you could get a DAB radio for $24. $24. Now, an equivalent AM FM radio is $19. Digital radio has FM as well. And here's another example of a relatively new model that's come out. I think this was on Alibaba. Prices US dollars 10 to 18 in quantities of 5 or more. That's pretty good value. So it's to establish receivers in a market and maybe do some initial subsidies. You can get these receivers even with color screens for very reasonable prices. And I just discovered another new one today. Well, not today, yeah, the other week when I was putting it together. In Germany, there's a camping radio, and it's got a light in the radio. It's fantastic. You know, so you could use this not only in camping, it could also be for emergency purposes because it's battery powered. Of course, in the automotive sector, we have virtually all brands now supporting DAB+. I recommend going back to see the automotive workshop if you want some more details about how things are moving forward there, particularly with hybrid radio, which we'll talk about more in just a moment. In fact, we can talk about it right now. So hybrid radio, I just want to emphasize this because this is really the direction of the future. This is where we use DAB plus transmissions to deliver audio and basic metadata like text, some images like slideshow and other bits and pieces. And we also can receive information through IP. Now, this is being implemented in a lot of new vehicles. And we can see this, what the online connection can give us here. It can give us more seamless experience if we move out of service area and want to go for an online streaming alternative. It allows tagging, new radio functions, high quality content for logos and slideshows. So slides don't have to be in QVGA anymore. They could be in high definition, as we have many cars today with high definition screens. Typical brands that are doing this now, and this has already been implemented in several brands such as Mercedes, BMW, Audi, Porsche, Skoda. Renault has now recently joined the group as well. So a large number of major brands are involved with this, and this is just the tip of the iceberg. Yesterday, I talked a bit about also implementing hybrid radio in home products, and that's not particularly difficult. We just need to get broadcasters behind that. And once broadcasters get behind that, so will the radio manufacturers. It's not a difficult thing to do if you've already got Wi-Fi in a smart radio in the home. It's an easy add-on. In fact, Frontier Silicon or Frontier Smart Technologies did that over 5 years ago with one of their products. And finally, okay, let's summarize and we can move on to some equipment. So DAB provides a wide range of advantages over traditional analog radio. It's more spectrally efficient and to allow significantly more services to be provided in an area. It's very high audio quality, and broadcasters can optimize quality versus bit rate. And that means you can think of that as quality versus number of services within your allocated or you'll allow total bit rate. We have program associated data for additional information, our advanced features and data services, increasingly hybrid capabilities, and most importantly of all, receivers are now widely available for domestic and automotive at very reasonable costs. In fact, in most cases these days, DAB radio is included at no extra charge in cars. So with that, I will conclude this presentation, and I will now hand over to Wolfgang to do his presentation on multiplexing systems. So over to you, please, Wolfgang.
Yeah, hello. Thank you, Les, for the introduction, and hello from Germany. It's a pleasure to join this meeting, and I would like to explain you some general aspects of DAB headends and how these can be realized in concrete terms. I will share my screen that you hopefully see now. Okay.
Yeah, that's good.
And yeah, oh, it's good. Time is short. We start right away with the principal structure of a DAB headend. And to make sure that we're all talking about the same thing, I give you a brief overview of the components of a DAB plus headend. A DAB headend consists always of one or more service providers that are here the green blocks in my block diagram. Each one can have one or more audio programs. You see here the upper blocks with one program, so service provider and has two programs, service provider 3 M programs. And you can have also service providers which offers only data services, for example, TPEC data providers. Yeah. And of course, we have one ensemble provider in the middle, the core of everything, which handle all these services. And of course, we have the challenge for the remote service providers here on the left side. We have to bring the audio signal via the contribution network to the ensemble provider. And that's typically done by MPLS lines or IP lease lines, and sometimes also via internet. Don't forget, for the service providers, as Les already mentioned, PAD is also really a benefit for the listeners. I personally love to see the photo of the presenter of the program or the CD cover to recognize which artist is behind this nice song. Yeah. And therefore it is really sensible to provide a way to transport audio, but also data and other signaling information. Very important for the equipment is the transmission protocol between the service provider and the ensemble provider is not standardized. As common standard between all the manufacturers, we use very often ADI to combine different manufacturers, but all the manufacturers have typically their own protocol inside. Yeah, so we are using here as the so-called AVT MUX protocol. Fraunhofer is using the MUX-ENG protocol, and other manufacturers use probably different other protocols. In general, all services are combined into a multiplex operated by the ensemble provider. And usually we have 16, 20, up to 24 programs in an ensemble. Yeah. But don't forget, DAB listeners expect good audio quality. If you have too many programs with a too small bit rate, then it sounds really worse, and that's not what we want. Yeah, so you have to really find the right way to have good audio quality and, of course, enough interesting programs in the ensemble. The output of the ensemble provider is ADI, or still the old format ATI. But in case of ADI, which will be the future or is already the future in a lot of headends, then we use MPLS or IP lease lines to transmit the signal to the transmitter sites. And of course, we do not use here internet because of reliability reasons. Important. DAB is almost broadcast in a single frequency network. Yeah, that means you need also a common time reference that is typically NTP, which is sufficient, but the NTP should be derived from an GPS clock to have everything synchronous. Yeah. When we start implementing a DAB headend, the first question is always, how can I transmit my audio program to the ensemble multiplexer? That is the typical way if we install an head end with a lot of commercial broadcasters. They are completely independent from the ensemble provider. And of course, they have the request to bring their program as well as their data to the ensemble provider. And in the following, I will go over the pros and cons of the 4 usual possibilities. There are, of course, different other possibilities, but the most 4 usual possibilities I will explain in detail. Most common suggestion is to use existing web stream encoder, which is understandable because you need no additional encoder in the studio. You can use your existing web stream internet radio encoder. You need no additional transmission channel. You have a complete separation between the DAB head-end provider and the contribution network. So you can set up the contribution network, in that case, completely independent from what the ensemble provider is doing. Yeah, that's sometimes a benefit, but depends, of course, on the platform operator. And but the cons of a web stream encoding is in my opinion so dramatically so that I'm not really a fan of web stream encoders. And if you're using the standard web stream, which you're using also for internet radio, then you have typically MP3 or AAC, and that will degrade the audio quality. Especially if you in general, if you cascade audio signals via different audio codecs, you decrease the audio quality. Yeah, and therefore you should avoid that. If you want to use it, then use at least a flex stream, yeah, which is lossless. Another big problem is the very high delay, typical 30 seconds for a web stream encoder. And that means if you are using also the DAB FM linking service or something like that, or the following, or a backup, the web stream encoder as a backup, then always if you switch to FM or if you switch to the backup, then you have a big jump in the audio signal. Yeah. And that's not really good. If we are driving here to Germany, and I very often have not an FM reception, in the DAB reception in special regions, and then we switch automatically to FM. If that would be an web stream encoder on the other side, then I hear really always a big jump in the audio. Yeah. And the other point is you have an internet connection, and that is not really reliable. If you lose the internet, then you lose always automatically the DAB service. Yeah. And web stream encoder and redundant headend is also almost useless because the main problem is here the internet connection. That's the main reason that the connection fails, and you have to pay for redundancy, and it makes no sense if you're working with a web stream encoder in my opinion. Okay, the next option is to use conventional audio encoders and decoders. That's a well-proven standard. You can reach perfect audio quality if you're using PCM codecs, and of course you can use the conventional audio encoders via MPLS networks. You can use it also via internet if you like. There are different secure streaming possibilities which offers better reliability. And of course we have still the separation between the contribution network and the DAB headend, so you can set up everything completely independent. But you need additional audio equipment. That means you need an audio encoder in the studio, you need an audio decoder at the ensemble provider side. And that means if you have more systems, then you have more chances to have a defect of a system. And of course, if you're using an high compression audio codec and not a PCM codec, then you have again the problem with the degradation of audio quality. The PAD insertion, the same as was true for the web stream encoder. PAD insertion and announcements are of course possible, but you need additional equipment. Yeah, and therefore it's also, yeah, it's also not the best solution in my opinion. Let's go to the third one. The third one is the contribution via RS-67 streams, which becomes more and more interesting. RS-67, it means a feed via audio over IP, like Ravenna. Yeah, so there is not really an audio codec on the service provider side. If you're already running RS-67 streams or Ravenna streams in your broadcasting studio, then it could be an idea to transport this RS-67 stream directly to the ensemble provider. Of course, it's perfect audio quality. It's typically PCM coded. You have still the separation between contribution network and DAB headend. And the current DAB encoders offer directly RS-67 inputs. So there is no need to convert something. You can simply put the stream into the encoder. Yeah. MPLS is typically a must because RS-67 streams are almost multicast. You can set up also a unicast, but most RS-67 streams you set up are in multicast, and then you cannot transmit that via internet. Therefore, I have put that in brackets. The RS-67 streams requires 2 megabit per signal, per stereo signal. And if you are the ensemble provider and you have 20 service providers, that means for you, you have to manage 40 megabit. If you have a redundant network with 2 streams, then you have 80 megabit. And that means it is expensive if you have an MPLS line here. Yeah. And therefore, it's also a little bit a problem. And the other big point is you need to synchronize the RS-67 network at the provider side with a grandmaster clock. Otherwise, you will have dropouts in the audio signal. PAD and announcements is the same as before. You need additional equipment to do that. With the last variant, the DAB encoder is installed directly in the studio. And in our experience, that's the most frequently used and also the most efficient variant. Yeah, the pros, the best possible audio quality. You have only one encoding in the complete chain. So the encoded signal is directly routed to the ensemble multiplexer. There's nothing in between. It's really bandwidth saving. You have 100 kilobit here at the output of the encoder, and that you can transmit simply via the internet. Or if you need more reliability, then of course you can also use MPLS lines, which are then not that expensive, yeah, because it's only 100 kilobit per second. And the modern encoders also offers a control return channel. So you can simply control from the multiplexer side the encoders. So you can remotely set up the bitrate, you can set up the mode and so on. That's all possible with current DAB encoders. Big advantage in comparison to the other variants is here, we can direct insert PAD as well as traffic announcements, for example, which is possible via a simple GPI. And PAD you can insert via simple FTP. So you have everything in one box, which you can then transmit to the ensemble provider. The only disadvantage, if it is really a disadvantage, there is no separation of distribution and network and DAB headend. So it is one side in general. Yeah, so the encoder and the multiplexer must operate together. You cannot set up it independently. You have to set up both at the same time. Yeah, of course, all the 4 solutions make sense. You just need to find the right solution for you. The 150 plus headends we delivered are all different. Customers have different requirements and you have to find the right solution. Let us come to another big point, DAB headends with redundancy. Yeah, why redundancy is important? Of course, DAB is a broadcast system, yeah, and listeners do not accept a lot of dropouts or a pause of minutes. And also an availability of 99.99% means you have a loss of audio of 53 minutes per year. You must decide if that is acceptable or not. but typical causes of downtime is simple power failures, error in distribution networks, or simply a system firmware update. Yeah, and then you can have immediately a problem. And to be totally clear, if a non-redundant multiplexer fails, all programs in an ensemble will be interrupted. Yeah, so high availability can only be achieved with a redundant system. And of course, in general, both encoder and multiplexer can be redundant. On the service provider side, each service provider can decide for itself whether to provide audio backup or not. For the redundant audio contribution, you can use the above variants, which I explained before, as you like. Yeah, but there is no need to have really a redundant audio encoder. But if you think you need that, then you can simply add a redundant encoder, and that can be a web stream or a conventional audio encoder, whatever you prefer. You see also that we do the audio transmission in a so-called cross redundancy. So each encoder transmits a signal to both multiplexer if there is a redundant multiplexer on the other side. Yeah, that gives you better redundancy possibilities. So if the line fails, then we have still the possibility to transmit the signal here via the second pass. And as I explained, redundant multiplexers is, in my opinion, a must. Yeah, if you have really a broadcast system, then you have to use redundant multiplexers. Yeah, and very important, if you have redundant multiplexers, all transmitter sites here on the right side must receive the signal from either the main multiplexer or from the backup multiplexer. It is not allowed that a few transmitters receive the signal from multiplexer main, and a few transmitters receive the signal from multiplexer backup. Yeah. If that happens, you would interfere immediately the SFN, because the output is not 100% exactly the same. Yeah, and that would significantly degrade the reception in certain regions. Yeah, so that you have to take in mind, and therefore we use typically to avoid that redundancy switches, external or internal, and integrated in the multiplexers to solve this problem. So finally, I would like to explain two example headends that we have realized. Both solutions allow regional headends for 16, respectively 17 regions. But we will see in the next slides, the requirements and the implementations are completely different. Let's start with the first example, which we have realized for the public broadcaster NDR in the northern part of Germany. The big challenge here was the high number of different programs. The requirements in detail were 16 fully redundant encoder and multiplexer DAB headends. Each multiplex contains 8 to 9 programs. At the public broadcasters, they have always a little bit more space for bitrate, so they can transmit high quality audio signals. But that means in total, we have here 2 times 129 programs, in total 258 programs for this service provider, NDR. Other request was, of course, PAD channels for each audio program. Each multiplex has its own NPAD channel, TPAC, SPI, for station logos and for the program guide. And of course, services, if you have a lot of regions, that is also a must to have service following and service linking. Yeah, otherwise, you have not really a clear structure in your network. And the last requirement was to connect external commercial broadcasters. That was a political decision from the government. So, and how we realize that? We have here the main and the backup multiplex. And the original audio signal comes from a Lavo audio router via MADI. And to bring that into our systems with RS67, it was really very quickly clear that the only possibility to bring 129 programs in each chain of the multiplex via RS67 into the encoders Otherwise, you need a lot of cables and so on. That makes no sense. And therefore, we had immediately decided to go ahead with RS67. So the direct out converter changed the signal from Mali to IIS, and the RS67 stream goes directly into our multiplexer, which has integrated audio encoders. We have dedicated slideshow servers from the company 4=1. We have additional servers from GEWI, which offers the traffic announcement, the dynamic label, and the TPEC signal. The SPI for the ARD broadcasters comes from a central location, central station, the RBB in Germany. Yeah, and then of course we have an integrated redundancy switch and a monitoring functionality so that you can monitor everything. And here in the photo, you see the realization that that's a complete equipment in 2 racks for the 16 redundant headends with in total 258 DAB+ encoders. And on the left side, that I forgot, you have of course the external program provider, the service provider, which brings the audio via an MPLS line or internet to the public broadcaster NDR. The last example is we did for the implementation for Polish Radio and Emitel, and that project had 2 challenges. The requirements were 1 redundant national DAB pre-multiplex with 10 programs, 17 regional multiplexes containing the national multiplex plus 2 regional programs, in total 44 programs. And that is challenge number 1. They asked only for N+1 multiplex redundancy for the regional headends. Yeah, so no N+N redundancy. They ask for N+1 redundancy. Then parallel ADI and ADI distribution, the data service as before, the standard TA, TPEC, DLS, slideshow. And the second challenge was they asked for a nationwide crisis announcement simultaneously in all ensembles and programs. And we see here the realization in the block diagrams. Interesting to know, although there are 17 regions, all of the equipment was mainly installed at only 2 sites. The national programs are provided by Polish Radio as a pre-multiplex, so they have installed the encoders as well as the redundant pre-multiplexer in their site. All the 17 regional multiplexers are installed at the platform operator Emitel. Yeah, regional encoders are installed either in the regional studios or at Emitel site. Here you see the N+1 regional multiplexer and the function in short words. The regional multiplexer receives all streams, the national stream, the national multiplex, pre-multiplex stream, and all the encoder streams from all 17 regions, so 34 encoder streams. And this multiplexer monitors all the different regional multiplexers, and if something fails, then we switch automatically to the N+1 multiplexer, which then take over the faulty multiplex. Yeah. And because that was also a request from Emitel, they want to give prioritization to different regions, to more important regions, and therefore we have also integrated a priority. So you can say region 1 is has a higher priority than region 2 and 3 or something like that. Of course, such an N+1 redundancy you can increase to N+2, N+3, whatever you like at the end. And here on the left, the last point is the crisis announcement. That it's a simple additional audio encoder, and if the Polish authority, that can be the Polish Radio or another authority, press the red button here, then we immediately seamlessly exchange all the audio programs in all ensembles as well in all regions. Yeah, so that was, of course, we could split the signal on dedicated regions, but that was not the request. They asked for an announcement nationwide, and that is simply possible. So that it's really seamless, because we use here the technology from our tunnel break-in systems. So the receiver will not recognize that there's something happened with the audio. It's simply now, instead of the normal program, the crisis announcement listenable. Yeah. So all listeners will hear at the same time the announcement. Of course, this switching is compatible with the current emergency warning function, which we heard yesterday from the guy from the what was it? Who was it? From the Digital Radio Bureau Deutschland, Carsten Sorger. That's all from my side, and question we can answer then later in the Q&A session. Thank you very much.
Thank you very much, Wolfgang. A very informative presentation there. Particularly intrigued by the N+1 redundancy, but we'll see if we get some questions on that. I think we should move on straight away. We now are going to go to transmitters and transmission systems. So over to Alexander Kurz from GatesAir. Over to you, Alex.
Thank you very much, Les. Good morning and good afternoon to everyone in the audience. I see we have nearly 140 attendees, which is a really nice number. Let me go and share my presentation. So anybody confirm that you're watching the presentation?
Yes, all good.
Okay. So today we're going to take a look at 3 components in the DAB transmission. The overview of DAB is essentially we're looking at the audio and multimedia service system that has a common transmission infrastructure. As previously mentioned, most of those are operated in SFN mode. Of course, some smaller operators have multi-frequency networks because they have like only one transmitter in a physical location. It's compared to television, it's relatively narrow band. It's 1.5 megahertz. Technically, it operates in the same frequency band as other operators are operating television. It's the band 3 of the VHF frequency range. That's around the 200 megahertz range. And you can, as just previously mentioned, you can have multiple audio signals in this channel. Some people also try to use it for video delivery. Now, the way how you get the signal from the multiplexer to the transmitter is a wide variety. Most customers today use either fiber, satellite, or microwave. There is a certain small number of operators who use the public internet as a backup. Usually you have to use some protection mechanisms, codecs that allow you to transparently deliver IP signals. And there is no analog multicast. So different to other digital radio systems where you have analog and digital on the same frequency, here it's only one system. So what we've seen before is the general overview, and just right now from AVT we learned about the service providers and ensemble provider. I will focus on the part on the right hand, the transmitter network provider. In many cases, the ensemble provider and the network provider are the same people. In some cases, they were separated. A general transmitter consists of either single drive or dual drive, which means you have a transmitter, which is that component down here, where the power amplifier is connected to an exciter, which converts the digital input to RF signal, goes into the power amplifier, and these two exciters talk to each other or have an external control that switches between exciter A and exciter B. For synchronization in single frequency networks, you need to connect either to your own internal GPS board, or you have a 10 megahertz 1 PPS signal available on site that allows you to operate the transmitters synchronous to each other. You see that there is a lot of connections going back and forward. The modern digital transmitters have usually a real-time adaptive control or correction that allows you to compensate for linear as well as non-linear errors in the system. A transmitter is then, because of its characteristics, needs a bandpass filter and usually also a low-pass filter, because there are harmonics that will be in the higher frequency range, and there will be interference, or if you look at the spectrum, there will be peaks left and right of the desired output signal. So the bandpass filter eliminates the interference with other channels, whereas the harmonic filter eliminates the multiples of the actual payload signal. So let's say you're transmitting in the 190 megahertz band, or calculation make it easier, in the 200 megahertz band, then you will have echoes in 400, 600, 800 megahertz, and bandpass filter have an upper frequency limit. So anything that goes above that, you need additional filter. After the bandpass filter, you usually have a directional coupler that allows you to feedback the signal into the linear, the real-time adaptive correction, the RTAC. And you have usually one open port here that allows you monitoring of the output signal. And from there, from the directional coupler, usually you go to the antenna. In some cases, you have combiners in between, but in most cases, you go directly to the antenna. So this is dual drive. Of course, if budget is an issue and you're limited, you can eliminate exciter B. That's an optional item. You don't necessarily need it, but as we just learned, the reliability and outages are a key element. And usually power amplifiers are constructed in a way that if you lose a power supply or if you lose an individual transistor, it still keeps operating without much impact on your output signal. The other way, especially in the low power section, is for redundancy operation, is to use a 1+1 system. That's not really new. That's been around in television and FM radio for a long time. By the way, dual drive as well. And the key element in 1+1 systems is you need a component that switches between those two systems. So you, at some place, you have a switch that is controlled from the control logic and says, okay, I want transmitter 1 on air, or I want transmitter 2 on air. So right now we have the spare transmitter switched to the output, whereas the regular main transmitter is switched to a dummy load. The dummy load is usually used for verification that your transmitter is okay and operational. So what customers do is they run the system on the dummy load for a while before they switch over from the spare back to the dummy load. And the rest of the system is basically the same. Now, if anybody is confused by ASI or TSO over IP, the ASIA is the ETI and the TSOP is EDI. the graphics for a TV transmitter and a DAB transmitters are identical, with the exception of the labels that you're using. Now, transmitter power levels, what is available? So Gates Air, we make these things. We are a producer of transmitters. It starts with very low power levels, around 15 watt for local transmitters. The upper series here is a very compact design, allowing you to have either satellite input or EDI and ETI. They are completely independent. You don't need any additional equipment. And that goes up to about 750 watt. And if you go with air-cooled or liquid-cooled in rack-mounted version, that goes up to, as you see, up to 45 kilowatt, which, to my knowledge, is not installed in Europe. The typical powers that are installed in Europe are between the 15 watt and a very low level, up to a couple kilowatt. So, for example, TDF uses 2 and 3 kilowatt transmitters. The next slide is what to consider, and here I'd like to stay a little bit longer. The redundancy concept, as I have described it before, is a key consideration when you deploy transmitters. Do you want single drive, which is 1 + 0? Essentially, if something breaks and the transmitter has no internal redundancy, then you go dark, or at least you lose output power. So in a rack-based system like this one on the right, you got multiple power amplifiers. You lose one complete power amplifier, which is very unlikely, then your output power goes down by a few decibel. If you lose the exciter and you don't have a dual drive, then also you have no output signal. So the usual consideration is single drive, dual drive, or in the low power, the 1 + 1 redundancy. Now, why I'm writing with without switchover unit is several modern manufacturers have the capability to switch between the two transmitters with an internal board. In some cases, you need an external switchover unit, but especially for 1 + 1, internal board is sufficient and a key cost-saving factor. Of course, the other considerations are output power. How much power do I need on air? The output power is not only the transmitter, but it also is influenced by the RF feeder line. So you have losses there. By the mask filter, by the low-pass filter, again, you have losses there. And the antenna system you're using. Now, I'll talk about the antenna in a little bit more detail, but essentially the antenna gain is the key factor here. When you look at efficiency, most modern low power transmitters, starting with 80 watt, have a Doherty technology, which is much more efficient than the traditional AB. We see different requirements for MER, and depending on MER, the efficiency can be adjusted. So if you go for a lower MER, you get a better efficiency. Of course, with a lower MER, you get a worse reception in the receivers. So this is something to consider, and ideally you talk to your friendly consultant or equipment manufacturer. Input options. I already mentioned that we have EDI, ETI, but there's also RF and satellite. So what we see, for example, down here is an input board that has an RF input. This allows to build DAB repeaters or transposers. So it can be an on-channel repeater or it can be a transposer to a different frequency. One word of caution, we're playing in the VHF field. The coupling between receiving antenna and transmitting antenna is a key element of concern. You have to be very careful how to lay your RF lines, and typically you need a good quality here. Satellite, that's not showing on this slide. We have an operator in Italy that operates about 100 DAB transmitters with satellite receiver, just recently starting to move to EDI. It's a good technology, stable, and you save on the distribution infrastructure. And if I'm considering some of the larger territories, it always depends how good the fiber network or microwave network is being built out. Consideration: air cooling versus liquid cooling. This unit over here is a liquid cooled system with an external heat exchanger. Now, one thing to observe here is that it's got redundant fans, so you can lose one or two fans and can still go on full power. The typical liquid cooling has redundant pumps as well. You got to pay attention that the pumps are in parallel, so if one pump fails, that you can remove it without stopping the complete system or without needing to switch over to a bypass or anything. Ideally, it's fully parallel. Air cooling is typically used for low power up to a few kilowatts, and liquid cooling is typically used from a few kilowatt. I mean, you can go to 1.5, 2 kilowatt, up to the 45 kilowatt I mentioned earlier. Now, why is this kind of separation? Liquid cooling immediately adds a significant cost factor for the pump system, for the heat exchanger, and the technology, how you have to build the power amplifiers, is different. In air cooling, pay attention to have redundant fans like you see here. So one fan fails, the complete system still operates at full power. The last item, the use of the transmitter in full frequency range, there, especially in the earlier days, and some vendors still have it today, you want to be able to tune your transmitter the full frequency range, 170 to 240 megahertz. Now, that in some cases you need to remove the transmitter, set some jumpers, or solder some elements. It's not critical as long as you only have the installed base. It becomes a topic when you look at spare parts. So it's something to consider. The other considerations I'd like to highlight is how easy it is to maintain the system. If I'm looking at ASPU as well as ABU, your territories are very hot. Some of them are very dry or very humid, close to the sea. So the reliability of electronic equipment is sometimes limited. We do something that we call tropicalization, which means we harden the equipment against salt and heat and humidity, but still you want to have a fail-safe system design, which allows you to have failure of one power supply and still have 100% of output power. You lose two power supplies, you have 50% of output power. So to lose a power amplifier because the power supply fails is very unlikely. The power amplifiers, you want to have them are the power amplifiers, but also the power supplies, you want to have them hot swappable. So you pull out the power supply, push in a new one. And the redundancy of fans is what I mentioned on the previous slide. Another consideration is a low pass filter or harmonic filter, if it's internal or external. We have both variants.
Sorry, Alex, to interrupt. Sorry to interrupt. We're really running out of time here.
Yeah,
Just wondering if you could accelerate a little
I'm
bit.
at
That would be
15 minutes right
appreciated.
now,
Okay.
so I'll be brief, but out of the 20 I had, I'm at 15. So low pass filter, internal, external, mask filter, is usually a third-party product from our side. You have to consider what you need. The control, typically we recommend HTML5, which allows you to control the transmitter via any device that is a web browser. And then for single frequency networks, you can have internal or external GPS signal. Antenna considerations, basically, you got to figure out which frequency range you need the antenna for, which polarization, horizontal, vertical. Radiation patterns is critical. For example, if you have a transmitter tower on the coastline, do you want all the energy towards the land, or do you also want some on the sea? So this example here shows nicely how you could have it designed here. I mentioned the gain before. The number of bays, you see that you mount the antennas on top of each other. More bays means more gain, but at the same time, it also means more load, more wind load, and more weight. Tower design is a point that sometimes is an issue if it's triangular, if it's rectangular in this thing. And then I mentioned before the RF feeder, where you typically have a loss over length characteristic. So the thicker feeder gives you more energy at the end of the line, but it costs a little bit more. And now you can do the calculation how much you want to invest. And this is the last slide for me, so that hopefully makes you happy. The monitoring part, I honestly stole these slide and the description from two vendors, Diva and RF Mondial. The RF Mondial is also a head-end provider. In the monitoring, you typically do a transmitter monitoring. So you look at the RF characteristics, you verify that you have the right content, but also in some cases, monitoring means you drive around with a vehicle and do field measurements and verification. Of course, you want to record this, and ideally you have SNMP capability and remote capability. So if you install one of these monitoring devices next to one of your high power transmitters, you want to be able to monitor it from remote location. And that's actually finishing my presentation. Thank you very much.
Thank you very much, Alex. There's a lot of information there, and it's clear that designing transmission systems is a complex situation. We know Gatesair are a very popular brand, very reliable and used all around the world. So all high quality stuff. Okay, now we're going to move on to the panel session. And talk about some experiences in establishing DAB around the world. We have experiences from 3 different countries, and we're going to start with South Africa. So please welcome Dave Cherry. Over to you, Dave, to give your brief presentation. Thank you.
Thank you, Les. Welcome to everybody. Good morning and good afternoon, wherever you may be. We'll present, and I'll share my slideshow. It's very, very simple, and just so that we could just talk about what we've done. See how we can get that up. Oh boy, here we go. If I just do this, I'll get it up there. The problem arises now. Does anybody see that slideshow at all, Les? Or have they lost it? No.
Not yet.
Okay. Right. Now this is where this, I find as soon as I go into a huge slide, that will give it to full size. It disappears. Then you go to, I need to go back here though. Get rid of that. That's not what I want. I want to just make this. Actual fact, what I've lost is the zoom. let's just do the share. It's there. All right, if I go there.
There we go. You can make your full, that's it. Beautiful.
Okay, thanks, Les. Sorry about that, folks. Okay, so just go on to our first slide. We talk about the introduction of our South African trial. We had SADiBA, which is the Southern African Digital Broadcasting Association. It's a member of WorldDAB, and the NAB, National Association of Broadcasters, which represents radio, TV broadcasters, public, commercial, and community. And we got these two organizations came together to form the committee that would actually, or the organization to run the South African DAB Plus trial. This trial originally started in 2012 with the admin side of things and went on air in 2014. And you will be saying to yourselves, well, hey, why have we been sitting so long on a trial? But we'll get to that in a couple of slides later, but it's something to think about. One of the very first things we had to do was the rules of operation, which everybody signed, got together, and they all agreed it was transparent. So all three tiers of broadcasting were involved. That's public broadcasting, commercial, community, and we decided that a third of our MUX would be for community services as a trial. One of the very first things, obviously, ask ourselves, why a DAB Plus trial? We had a look at it and we said radio needed to be kept relevant to the digital age. The very one that I'd like to focus on, of course, and I think that affects most countries, is that there's no high power FM spectrum available for new entrants and expansion of existing FM services in any of SA's major metropolitan areas. And of course, DAB Plus will create extra channels and allow expansions of the existing services, because even existing services can't actually go out and fit gap, even FM gap fillers if they want to in our metropoles. Just to give an idea, if we have the public broadcaster, it has 19 radio services, because we have 11 official languages, which will soon go to 12, but 11 official languages, all of these, they have 19 services, and all of these occupy a single FM transmitter, one frequency, and of course, there's a range of gap fillers that goes with this in the metropole, so it eats up a lot of capacity. So obviously, DAB is fantastic technology to actually take all those BBS services onto one particular MUX. DAB technology, we all know, well established worldwide and growing, numerous success stories in the world. The receivers are, of course, widely available. Traditional radio listening is not being replaced by internet radio. You've just got to ask commercial broadcasters to switch off his traditional FM service and go onto the internet, and they will not even consider it. Not in our part of the world anyway. Advantages of DAB, I'm not going to focus too much on it because we all know efficient use of spectrum, economical low power per audio service, consistent quality of reception. One of the interesting things that that does cause an issue is all broadcasters on the MUX have exactly the same coverage. And of course, if you have community, commercial, and public, the commercials are not happy that the community have the same range because they pay a higher license fee than the community. And so there's a bit of a squabble on that. And that's what we have, you know, that's a highlight that we came across. Of course, it retains the same FM capability of portable mobile coverage, enhanced visual services. We've tried in our trial, all services had to have slideshow and DLS, and we used a particular program to create that at that particular time. What we did for the purposes of our trial, we wanted to test the end-to-end technical functionality studio to receiver. So we've looked at all sorts of MUXes. We've looked at cloud-based MUXes. We've looked at open source software. We've looked at professional, and we've tried them all. We've still got a couple to still go through. We looked at the extent of portable mobile coverage with the moving vehicle in South Africa. We have a couple of large German manufacturers from BMW, Volkswagen, Mercedes-Benz, and they've all come to the party with provided vehicles with DAB receivers. So we've been able to check that out against. Signal permeability was a big thing for us, building penetration with the size of cities with lots of concrete, underground parking lots, huge shopping centers with huge underground parking lots. We wanted to make sure. And so in the end, we ended up choosing to use 10 kilowatt transmitters, and because the XTV antenna system, or still TV, is 100 kilowatt ERP, and we decided we'll start at higher power, and then if we find it's too much, we can come down. We'll do tests at 5 and 2 kilowatts, which we did. But to be quite honest, to get the decent building penetration loss, the 10 kilowatts is what we're going to do for the big cities. We've looked at interference clutter on coverage, demonstrated as services. As I said, there were pictures with slideshows in that earlier on. Our public broadcaster ran news bulletins, which came from sports, business, and news. And then we did field testing of typical professional consumer equipment, where we've played with, looked at receivers. We had a whole batch of receivers that would go out with the signal testing van, so that they would check against all different models and makes to see that they all perform much of a muchness. And funny enough, they did. We have spent an awful amount of time on audio quality at different data bit rates, feeds. Obviously, we've come to the conclusion that internet feeds are, or open internet, the last resort. To get the codecs to work properly, to actually use linear feeds into them, and then they actually sound good, even at quite lower bit rates. And then challenges experience, which will be come to the end of the thing. Delays in procuring band VF3 spectrum in South Africa is a problem, and this is why we have this long delay. We were supposed to have our analog TV switch off since 2015. We're still waiting. Some of it has gone off in a couple of provinces, but the final day is the 31st of December 2024. So nothing is going to happen commercially in our country until that band is clear, because the band that we've been allocated in the region 1 in this part of Southern Africa is currently occupied by a whole wad of television transmitters operating at high power. We were lucky enough to find one channel, which is channel 13F or 239-200 megs, where we were able to use that with existing television services on air. Of course, this delay of nearly 10 years has led to loss of focus by some in the industry, and that's a problem. They sort of with comments like, "Oh, when is it ever going to happen? Is it ever going to happen? You know, we've moved on, etc., etc." And maybe there's something new. It's a problem, but it's due to the spectrum problem. Also, we have a problem with trial period regulations as Liberty. We have an 8 months trial, and then we can extend it for 6 months. Well, it doesn't work quite as well as it should do, because you run out of your 8 months and you might have a month or two before you get your new license, and then you're off air. And the longer it is off air, issues with equipment either being used by somebody else in the trial or going there. And so you have to virtually start all over again from the beginning. And that was what we found. Delays in granting and license extensions also affect the flow of the trial. TX combiner issues, yes, when you're running with high analog TV running with 3 or 4 transmitters running, and you've got a DAB all running a 10 kilowatt transmitter, the combiner was a big issue. And we did have problems with one of our sites where it's very, very close to a television channel. And initially we couldn't get the 10 kilowatts over the 100 kilowatt ERP. But changing that combiner to a different brand, we were able to make that. And then just to finish off, our coverage in the Johannesburg or Gauteng area, which is the place of gold as it's known, gives that coverage. There's quite a big overlap. It's 100 kilowatt ERPs at both sites. We also have had a trial in Cape Town, which was a much lower trial. And just to finish off, the 10 kilowatt transmitter and one of the rack with the original equipment that has now changed, that we're actually feeding from a cloud-based offsite from the transmitter site. And then there's just the normal vehicle for going around testing, and there were very, very intensive tests done. And that should bring us to the end, Les, and I hope we made the 5 minutes or maybe just over it.
Thank you very much, Dave. Very interesting, the sorts of issues you've had in South Africa. I'm sure you're not alone with some of those, particularly in the spectrum domain. Very important to make sure you can get access to spectrum. Let's now move on to Thailand, and I'll introduce Ms. Orazri Sriraza to give us an update on the regional trial in Thailand and progress there. So please, over to you, please, Orazri.
Thank you, Les. Yeah. First, I would like to thank MODAP and ABU to giving me opportunity to share what Thailand have done for digital radios. And as you know that Thailand is the regulator responsible for frequency planning and also telecommunication and broadcasting regulation in Thailand. And the first important national plan is Digital Economy and Society and Broadcast Master Plan. The first Broadcast Master Plan, strategic number 6, transition from analog to digital broadcasting is mandate that have to transition to digital broadcasting in Thailand. In this regard, NBTC had developed the policy on digital radio deployment, and we start digital radio trial, network trial, and also service trial in Bangkok and vicinity area since 2018 and expand to regional area later. And the second master plan, the amended version is just revised and entered into force last month, June this year. Strategic number 1, it developed the Thailand radio broadcasting business to meet the international standard with the dynamic and digital context. So the key target and activity that NBTC have set this year and next year and the year later, we have to grant the service, network service license, and also the to promote to develop the technical standard and to broadcast, to support the broadcast digital radio together with another platform like the online platform, and to set up the audience measurement system for the radio broadcaster, set up the broadcasting fund to support the radio industry. And next is a project. We have set up many projects about the digital radio. The first project in 2014, we have the joint project with the ITU. This project is to develop a radio roadmap and strategy to deploy a digital radio service deployment. We studied the technical possibility study to deploy a digital radio on available band, and we found that the VHF band 3 is available after analog TV switch off 2000s. So this band is available for digital radio. The plus is a relative option for Thailand as the ITU recommend because of the economy of scale and the technical system. And the first in the first quarter 2018, NBTC published the notifications on the frequency planning for digital radio. We set up the system and the technical data for trial for 10 major cities. And after that, we do many projects. For example, that we do the social and economic impact to the product digital radio. We organize many workshops for capacity building, and I believe that more than 1,000 people have joined this workshop in Thailand. And also we developed the handbook for digital radio, and we publish on the NBTC website. So the public or the broadcaster can understand what is a digital radio and benefit of digital radio. And right now we do the national project study. This year, we have the consultant and that we also got support from Dr. Les as well, and the procurer to do the network planning and cost estimation for network deployment. And also we do the economics impact or cost estimation to deploy the network. We do the demand survey, we collect the information from the broadcaster. And this project will be complete at the end of this year, so we know what we have to invest in the network part for digital radio deployment nationwide. And next is the example of the digital radio trial in Bangkok and main city. For frequency planning, we have 3 phases. We set up the frequency planning plan, and we start the radio trial the phase one we started in 2000. I think 2018 to 2020, we do the trial in Bangkok area. And we have the one transmitter site in Bangkok that can cover around 10 million people. And phase two, we improve the qualities, improve the coverage, and also the support the broadcaster to support on the software to manage metadata. And in phase three, this year, we expand the coverage to the regional area in major city, and NBTC support the funding for broadcaster and network operator to run the trial projects. And the green color is the main city in regional areas. And in trial project, we signed the MOU with the Royal Thai Army, that's the major broadcaster in Thailand. But we invite the other radio broadcaster to join the trial as well. The trial is aimed to do the technical test of signal measurement and signal parameter. For the receiver side, we test the receiver and we distribute approximately 5,000 receiver to the radio broadcaster and to the user. And we did the user survey after that to evaluate the trial projects. For service test, we test the new service and feature like GPEG, emergency warning, slideshow, and also with works well. Yeah. And with this capacity building, we organize the workshop for broadcaster. And this is the example of the coverage prediction in Bangkok. The transmission power is 10 kilowatts ERP. We invite the popular, the radio broadcaster, commercial and public broadcaster. And we try to engage the user or the public. So we organize the local contest from digital radio. And besides this, we do many conference and workshop we have the corporate with the incumbent radio and also the car manufacturer, the receiver, the other government agency in Thailand to support this. And also we got the support from the international or regional organization like the World AB and ABU to support us on the capacity building. We have the speaker from the regional or the expert from ITU as well to support this. And the last is the key success factor. From the country case study, we collect the key success factor that the regulators and the broadcasters should be take into account when they deploy the digital radio. This just for the example, the coverage, at least should cover 95% of population coverage, have the clear the deployment plan. For service, it should introduce a new service as well, besides the improve the signal qualities. And for the receiver, should promote the receiver in car and have the variety model like the hybrid radio. In Thailand, we have the cooperation with the car association and also the government agency like the Department of the Land Transport. And we have to collect the survey from the user to know the behavior. For the network facility, we encourage to share the network facility. In network planning, we utilize the digital TV site and also the FM the site right now and our telecom tower. So we encourage to use the existing tower and share the facilities. And also the important thing is collaborations. The cooperation with all stakeholders. We have organized a meeting to discuss with the network provider, the broadcaster, and also, as I mentioned, the car manufacturer and other government agency. And communication now, we in the master plan, we also set a target to create the understanding and awareness. We create the communication plan to the public to understand and are willing to adopt to digital radio service. So the last is I just a summary of what we have done in Thailand. Set up the policy, clear policy master plan, set up the study projects to and develop the frequency plan, do the trial or trial and technical trial if it needs. And important thing is a demand survey, because in Thailand most of our radio broadcaster they move to the internet radio, so we have to survey again before planning a network. And capacity building, communication, and the last thing that we have the NBTC fund. We developed the plan to the master plan to support the fund for the digital radio deployment in Thailand. That's all. Okay.
Thank you very much for that great description of the activities in Thailand. I think Thailand is really a good model. Have spent a lot of time and effort to get it right through the efforts of a number of trials, a number of collaborative projects, and so forth. However, let's move on and let's see how Tunisia has moved forward with DAB. So over to you, please, Kamal.
Thank you very much, Dr. Les. Welcome, everybody. I'm glad to be with you today to give you an overview about our experience in ONT, the National Broadcast Network Operator in Tunisia, regarding the DAB Plus project rollout. So during this presentation, I will give you some details about the digitization stages in Tunisia, followed by the state of force of occupation. Why really we roll out DAB Plus? Then you will have an idea about the digital radio trial and the strategy of deployment of DAB Plus in the coming years. Let's have an idea about our digital strategy. So the digitization era in the audiovisual field in Tunisia started or began in 2001 with the digital terrestrial experimentation platform, DTT. That was started in 2001 as experimental platform. The official digital TV network started in 2010, and the actual coverage is about 98% of population. The ASO was done in 2016, and so the VHF band is therefore free, responding to the digital requirement dividend. What about the FM spectrum occupation actually? So actually, really, we do have a congestion on FM spectrum, which is really full, inducing a lack of frequencies. And it's really difficult to innovate. No, we can't respond to the request of some new stations in some regions because there are no more frequencies, so no capacity for new services. The trial period started in 2008 by transmitting one multiplex of 12 programs, and with a national plan enables the transmission up to 7 multiplexes. This is the coverage during the trial period in 2008 till 2018. This is some photos about the equipment that was used at that time, the transmitter, triplexer, the encoding user interface at the head end. The actual DAB platform that starts in 2019, ensuring the transmission actually of 18 audio programs by installing 4 transmitters in the high sites all over the Tunisia. This is the graphical user interface with the local interface and the simple network management. These are some photos also about the transmitter, the triplexer or the combiner, the antenna system. This is the antenna VHF that was used for analog TV, of course. The actual coverage at the time in 2019, that was 51% of Tunisian population. In 2020, we moved to the second phase, and by installing some new other transmitters. having by that an extended coverage with 24% of Tunisian population. Actually, we have that coverage in Tunisia since 2020, more than 75% of Tunisian population. This is actual coverage. Rock blocks, recommendations, and solutions. This is the important part for broadcasters. So the actual multiplex that we have currently hosts 18 DAB plus stations. The coverage is significantly improved, reaching 75% of the coverage. We are able to go to 5 multiplex in the coming years, where we are asked to ensure the broadcast of other new stations that will have licenses from the Tunisian audiovisual regulator, HAICA. This is the channel allotment regarding the national frequency plan according to RRC 06 in Geneva. The second phase of the expansion was done in June 2020 and bring population coverage to 75%. Phase 3 and 4 have been planified in 2021 and 2022, but unfortunately, as you know, have been delayed due to the impact of the global pandemic, COVID-19, and also due to the worldwide economic conditions. So we foresee that in T3 2023, the population coverage will reach 90%, and T2 2024 will reach 99% of Tunisian populations. There is no doubt that collaboration is the key for the successful rollout of DAB+. So for the good implementation of the project, we carried out meetings and workshops as was done by some other colleagues from other countries during the last period with all stakeholders from radio stations, automotive sector, retailers, importers, wholesalers. So the aim was really to sensitize all stakeholders about this new project and the new digital ecosystem, and to underline their eventual problems regarding the smooth move to the digital world. This is an important summary from World DAB, stating that for the best development of the DAB project, we should have in mind to respect the 5 C's policies regarding the coverage, content, receivers, automotive, and marketing. We for sure have to continue experimentation of the project in all its technical and marketing aspects. 2 and 3, we are actually endeavoring to pass a law in Tunisia that all devices have to be sold to consumer by automotive industry have to be really capable of having receiving digital radio. This is matching with the European EECC directive. Today, as you know, almost all new cars in Europe have DAB+ standard. For we set a national committee composed of stakeholders from legislative and standard bodies. This is in order to develop a new national road map. We foresee that in 2024, that all devices to be digitally DAB+, and of course to get DAB+ in cars. In addition to, we have to set a solution on all aspects of switching from analog to digital radio, including regulation, licensing, technical trials, network build-out, and marketing. Regarding the action plan for DAB+ digital switchover, we invite broadcasting organizations to put flashes, as you see on media, as awareness plan. Second, we are also going to use the service to broadcast archival and specialized programs. Also, we are going to conduct exhibitions to advertise the product and all its prerogatives. The action plan has to take into account first the creation of national committee representing of Ministry of in charge of industry, trade, and communication to keep in pace with the process of transition to digital radio broadcasting according to the national roadmap. Second, we are in coordination actually with Tunisian Customs Service to create a new custom classification reference for fixed, portable, and mobile digital radio receivers. Why? Because we have to ensure that should work on the digital network according to DAB system requirements. We also are working on issuing a decision specifying the technical characteristics of digital radio receivers. Also, we are stating on the fact that the new cars have to be capable of receiving digital radio starting from the year 2024, as I said before. We are still in coordination with the Ministry of Finance, actually. Why? Because we want that they have to consider adopting tax-free exemption on receiver to reduce the selling price. This is a very good idea for audience, and to encourage local imports, as well as we did, of course, with DVB-T rollout project in 2015. We are still setting a timetable for the gradual transition to digital radio broadcasting according to a fixed roadmap. Also, an important point, we have further consideration regarding value-added services for data transmission with DAB, digital radio receivers. Regarding the quick change of audiovisual digital ecosystem, we can say that the future of radio is digital, and the standard to be used is DAB+. I want once again to point on the benefits of the migration toward digital radio, particularly the offering of more value-added services at lower cost, emphasizing that the time is now right for the radio industry to commit to a digital future. Thank you very much.
Thank you very much, Kamal. It's some very good presentations here. In fact, all the presentations have been very good, but I'd like to just highlight the last couple where we see the difficulties in different countries. Every country is different and everyone will have their own path to walk down. And certainly there's a number of really critical points that we need to think about when we are looking to establish DAB+ digital radio. You know, first one is spectrum, and certainly Dave Cherry highlighted the issues there with delayed analog television switch off. I think from a cooperation and coordination perspective, Razri in Thailand and Kamal, in fact, Dave as well, have really emphasized the need for all stakeholders to be in communication and get together, ask the questions, work out how to move forward and have a plan. So, and finally, I think receivers are totally critical in these situations. There's always a push for lower and lower cost receivers. I think they're starting to get to the bottom of the cost range now, particularly after what we heard yesterday from Patrick Hannon. The actual receivers can be made for around $10 and sold for around 20, you know, in volume from you know, Chinese manufacturers, for example. Always a possibility to make them in your own country too, if you wish. Okay, we've run out of time. I thank you all very much for sticking around and listening to the end here. We will try, we've answered most of the Q&A questions directly, and we'll try and make a little bit more time tomorrow at the end of day 3 to have a few more live Q&A sessions, questions you might say. So at this stage, I say thank you very much to our panelists today. They've done a great job. I hope the audience, have really enjoyed it and learnt from our experts today. And I look forward to seeing you again tomorrow. Another great turnout. I think about 130 today. So fantastic. Thank you very much. And we will see you tomorrow. So thank you and bye for now. Oh, sorry, just hand back to ABU for sorry, Dr. Adnan, did you want to say something finally?
No, nothing.
Okay, we will now hand back to the ABU, our hosts, to finish off the session. Thank you.
Thank you. Thank you, Dr. Les, and also sincere appreciation to all the speakers, and most importantly, the participants for so many questions. So we'll be dealing those questions tomorrow. Okay, so that's all for today, and tomorrow we are coming up with even more interesting topics. So by the time, thank you very much. See you tomorrow, same time. Please tune in tomorrow. Please join tomorrow. Thank you.
Thank you, everybody. Tomorrow. See you tomorrow.
Thank you.
Bye-bye.
Bye-bye.
Thank you, everybody. Thank you. Fantastic. Good effort.
See you tomorrow.
Excellent workshop.
Bye-bye.
Bye.
Bye, folks.